All right, I think we just kind of set it up and check the lateral, the deflection under the surface with an XY direction. Now what we're gonna do, I think, so we're gonna create a few more concrete strengths. Let me double check this is correct or not. Okay, 44. Okay, for 4000 psi. Okay, 3604. So let's copy it. Maybe we can try 5, make it 5 psi. And since this is based upon 4000, I'm gonna use this built-up calculators, right? So because Young modulus is proportion to the square root f prime c, so I think I made it for 5000, right? Since we have a 6000, and I'm gonna copy, just make another 7000 psi. This is based upon 6000, right? So SQRT 7 divided by 6. All right, so for now I stop. I think this is enough concrete strength, and then I'm going back to the wall section since we had only one sections. So I'm gonna 24 inches. I'm gonna choose 7000. So make 7. So it's a lot of data. Also name kind of adjustment. So 618. Okay, I'm gonna use it for tail. I'm gonna use 5. So make 5, something like that, right? So section and material property and section properties is all set. So what I'm gonna do is, because I need to select the wall and then only, so go to set 3D view, put the X, Y and aperture 0. So I'm projecting down all entire and select window selection, right? And right click, show select only member. So what you can see in 3D, so you see the only wall. Control D. Okay, you turn off this. All right, now this checkbox doesn't work again, so I'm gonna switch this one. So we have a color view by the color section property. I'm gonna turn on since we're using only one section, right? It's same color. So I'm gonna put this one now XZ and aperture 0. So I'm just assume lower 1/3. I'm gonna assign this wall as, let's say, 24, right? Another 1/3 roughly. I'm gonna use 18. Oh, so 18 has the same color, so I'm gonna change the color 18. Okay, so maybe change the color. If you replace it, okay, now save it. So 24, 18, 12. I know you already have enough, but we'll see. Now link beam, I think we assign the link beam here 24 by 30, right? But typically the link beam, coupling beam, will follow the wall thickness. So previous one 24 by 30, but we're using 7000, right? So we're gonna adjust it, and then we're gonna create a few more. The link beam. Now wall thickness here is 18. I'm gonna keep the depth 30. This cases I'm gonna make 6000. So 18 by 30. See 6, right? 18 by 30. Okay, I'm gonna copy one more time. Link beam 12 by 30. C5. So concrete strength 5 and 12 by 30. Okay, so I made section property. Again, I'm gonna put it in 3D. So from here to here, right, this wall thickness is 18, so I'm gonna assign section property 18 by 30, right? So this is here. I'm gonna select this one. I'm gonna assign to 12 by 30 link beam. All right, so I think at least this is just a more reasonable. The wall thickness varies 24, 18, 20, 12, but with the various concrete strengths. So I'm gonna save this. Let's run the model. I'm sure since we're using a thicker wall thickness at the bottom, the deflection will go down. Running. Okay, I'm just pause. All right, so analysis is done. I'm gonna just double check again. The deflection due to the wind, let's say X. The maximum story displacement in X direction, you have a 2.18, which is actually reduced a little bit. Y direction, well, Y direction used to be a 14 inches, now 7.4. So basically, your building has very deep, 50 feet long wall, and also in X direction is much long. So you have a tremendous amount of the stiffness, so you don't have any issue. All right, so for this, okay, so up to here is a lateral load resisting system model. I show you. If you want to play around, change the wall thickness and concrete strength, do so. I think you have plenty of stiffness, so 24 inches might be not. So you maybe want to reduce the wall thickness and run that some two, 3 times iteration and summarize your deflection under the surface wind and X and Y. So I think that is help you to understand better. So I think minimum 2, 3 times. I think 3 times is perfect. Okay, so next one, what I'm gonna do, I'm gonna unlock, because now met, right? So since current model, we put some pin at the column and wall. These cases I'm gonna restrain, I'm gonna make it free. So basically now everything is sitting on the mat. So let's see what does mean this. So all the column is sitting on the mat. I don't know how much you extended. You extend a little bit, few inches, right? So this mat also has a spring constant, so there is a vertical stiffness. Okay, I'm gonna put this one in the X direction. Do we have an XY restraint? I'm not sure we have it. No, not yet. So I'm gonna assign, just otherwise this model gonna move X and Y. So let me see. Turn on the somehow I cannot clearly see where is my restraints. Here. Okay. All right. So now it's ready to run it, because I think you already defined the design strip here, there. Okay, and then let's run and see. Okay. Okay, so I think analysis done. What we're gonna do, we're gonna check the soil bearing. Do we have a depth plus live road? Okay, here. This is keep inches. Okay, let's check to keep and fit foot, and check the soil bearing due to the depth plus live road. Yeah, service depth plus live road. Maybe our target is minus 20 to 20 KSF, right? Let's see. Where's, no, maybe not. Oh, so only 2.5 minus, very small. Somehow, maybe because they're all negative. There's something going on here. All the reactions from the column. Seems like something going on here. That plus live load. Okay, let's check the load combination. No, wins. Okay, that's why. So this load combination, I need to, so, okay, dead load, span plus dead load, and live load. Okay, so this is the load case. We need to use it. Okay, let's see. Okay, minus 14 and 0. All right, so see that it's based upon due to the dead load and live load. So overall, the tower superstructure loads come down, especially majority of dead load come from the wall. So you're gonna see more intense the reaction soul bearing because more loading coming from the wall. But outside column loading is relatively small, so you're gonna expect something kind of bearing soul bearing stress like this, right? Okay, it looks fine. And since we have a design strip, let's check the design strip display. And here strip forces. This case is design forces strip. We're gonna use ultimate load 1.2, 1.6, and turn on and see how does it look like. So design strip, okay, we're gonna show only extraction, right? Extraction. See that positive and negative because the mat is just sitting on continuous spring. Y direction, you'll see that something negative and positive, same way. Based upon this design strip moment, then we need to design the rebar, right? Here in design, the slab. So first of all, we're gonna choose this mat design, okay? Go to design and start design. Before we do that, I think there is something we need to check it. Clear cover here. Typically bars, we're gonna use number 11. Inner slab bar is gonna be X direction. Clear cover, this should be inches, but we'll change it later. So it should be, we need to define because concrete will be pour on the soil, so clear cover should be 3 inches. But this is the cover from the bottom face of the concrete to centroid of the rebar, right? So it depends on how many layer you're gonna use. I think you need to adjust this clear cover. All right, for now, so we're gonna run the mat design here. But we need to check the load combination. All the load combination, ultimate load combination should be based upon the ultimate load combination. I think previously the load combination was maybe wrong. Why don't we maybe I'm gonna just in case, I'm gonna reset. So load combination here, default, concrete frame, concrete show up, concrete frame, okay. So when you take a look at it as 2, 1.2, 1.6, right? This live load should be reduced live load. Okay, so we're going there. Here, select design load combination. You need to use S series ultimate, and then so you're gonna run the design. Okay, so what I need, usually I show you during the class, so I'm gonna play with this flexural rebar. What you can see, you could also check the shear stress. Maybe I will show you here. Shear stress for each load combination S2, let's use S2, right? And our vertical shear stress 1.3 and 2.3, you can check it. Somehow you see the highest shear stress happening at the corner of the wall. Typically I use a PSI. I need to change this stress PSI. But you see there's some contour in S13 and 23. Okay, you're gonna see this, that whether this is shear stress, ultimate shear stress should be less than your concrete shear stress capacity. 0.75 times, 4 times square root of frame C. We're gonna talk about later. Okay, so I'm just spot checking that overall diagram looks reasonable, but we'll check the number later. So I'm just trying to show you here flexural strength design, rebar design. Let's start with the bottom bar and strip method, including minimum bar. We're gonna use number 11 as basic bar, right? And since this is fit, so when we throw out, right, number 11, okay, 1 foot on center. This is bottom bar. You still have a lot of additional bar right this, right? So maybe I'm gonna use 0.5 means double or 6 inch on center. Now you see the additional bar goes down, right? Let's change now it's 2 inches. So inches. Okay. There might be a shortcut somewhere here. I'll find that. So you can play around here, flexure bar, right? And bottom bar first, so 6 inches. Okay, still you have additional bar. If you want maybe 3 inches, doesn't mean it's 3 bar bundle at 9 inch on center, right? This is just about just basic math. What we need is total area of rebar needed, but you need to see that their own extent where is more rebar needed based upon all the moment, negative moment and positive moment. We are looking at the bottom bar, so mostly right here 3, maybe 6. Let's try. Okay, 3 or 4. Okay, maybe 3. Most likely 3 is all the typical bar. Number 3, 3 bundle, number 11, 9 inches, 9 inch on center will cover entire area except this mat, because we have a very huge moment. I think we need additional bar around this concrete core wall, right? So I think you can play around this top and bottom bar separately and show same thing, right? Something like that. And you can describe what's gonna be your typical bar, right? And you just play around this and then describe that, okay, your typical bottom bar number 11, 3 inches on center, or 3 number 11 bundle at 9 inch on center, and or top bar number 11, 6 inch on center, and then the screen right here showing this additional bar. All right, so I think this is gonna end of the video for the map foundation design, and I'm gonna just upload it.